move on to our next presenter, who is Jonathan Stanger, Director of Spatial Partners. Jonathan started his career in nanotechnology. We won't hold that against him. Holding a master's in physics and a PhD in materials engineering. However, the academic industry didn't really suit him, and for the past 6 years, he's been working in the GIS industry with Spatial Partners, much to our benefit as far as us in the spatial industry. By nature, he is multidisciplinary, which makes him a bit of a Swiss Army knife, probably the same Swiss Army knife that Dale was talking about, for data-driven challenges, mainly working with clients in the telecommunications and construction industries. I'd like to invite Jonathan to talk about taking it easy with temporal GIS inspections. Over to you, Jonathan. Thank you very much.
Thanks, Andre, very much for the introduction, and thanks to everyone who's taken the time to come and listen to this presentation. So from the title, you might be wondering, what on earth am I on about? And really, this is just a really fancy way of saying that we say we have a geospatial feature, and what we're going to do is we're going to regularly add data to it over time. And so the classic version of this kind of activity is really some kind of inspection. So things like an asset inspection or some kind of regular work activity that needs to be done. And it's where the real world asset is that's what the geospatial feature represents. But sort of runs into a bit of a problem if you have, say, the hypothetical situation. So say if you've got a client that has a large budget and a GIS support team, there's plenty of options out there on the market that'll do all the things for you, all singing, all dancing. But what happens if your client wants something that's a bit of on the cheaper end and maybe pure SaaS, because they're not really in the market to try and roll out a whole new large scale system? And so the options suddenly become a little bit more limited to be able to achieve this kind of thing, particularly if what you're dealing with maybe isn't necessarily suited towards very simplistic point-based inspections. And so what we were looking at doing here is, it's particularly the case if you're adding and removing features over time. So if you don't have the option to be able to stand up a whole database that you've got full control over, how do you manage these inspections without putting a lot of difficulty and complexity onto the user after you've left? And so with all of these considerations in mind, we decided to suggest combining GIS Cloud, which is a web mapping platform, a fully SaaS solution, along with a bit of FME magic behind the scenes, so that we could make it a bit easier. So the particular client that we were doing this with at the time is one that needed to periodically send a field user to perform an action on an asset on a schedule. In this case, it was a tree that needed to be watered after it had been recently planted. And the client really didn't want to have high monthly costs, wanted it to be able to scale with their users, how many users they had at the time, and they really definitely did not want to have to provision any new infrastructure or have to learn any significant GIS skills to be able to maintain this. In this particular case, it was actually because they had a new system that was planned to be rolled out in a couple of years, so that what they needed is something that wasn't going to stand the test of time, but something that would be able to bridge the gap between where they were now and where they were going to be in a few years' time. So the sort of example inspection curve, the example inspection task was that basically you would have a series of trees out there. If the tree was less than 1 year old, you'd have to go out every week to be able to water them. And if it was between 1 to 2 years old, then you'd need to be going out every 2 weeks to water them as they become a little bit more robust. And at least every 6 months, you should be taking the time to inspect the tree for any kind of defects such as disease, vandalism, or similar kinds of things that might be impacting the health of that tree, so that that health can be resolved. And so with that, it's a relatively simple, straightforward process. And so the GIS Cloud platform offers a fairly simplistic, but still providing a lot of the basic GIS features that you would come to expect from a modern product through their desktop interface. And one of the most critical things is that the people that we're sending out into the field, particularly in their case, didn't want to have to burden them with a lot of understanding about GIS concepts. So the mobile application is a simple map that shows your current location, allows you to see all the trees that have been watered and all the ones that are still pending. And then once you've clicked on something, to be able to start doing your watering activity. Very, very simple, straightforward form with a lot of expanding dependency questions. So if a defect was selected, you'd be able to open that up. Now, alternative platforms such as Esri could have been used, but in this case, we decided to go with the GIS Cloud one. Pretty much if there is some kind of online mapping platform that has an existing mobile application, it's this kind of workflow should be able to fit in. So the main thing that we wanted to do here is really sort of sacrifice quite a lot in terms of the data management side for the sake of making the actual tasks that our end users had to do as simple as possible. And so the process that we actually adopted was a very, very straightforward one, where effectively they had on the cloud-based system a master map. So this is where your core data is, and if they needed to add or remove any given features, they'd be able to add or remove them from this master map through a relatively simple form or just a simple delete process. And then each time they wanted to issue work out to their field inspection, field activity crews, you would be then duplicating that master map, which then preserves all your style configuration and allows you to manage on a week-by-week basis what the access permissions are for the users that are going to go out into the field. And then from there, you would then duplicate those layers, which provides, from the user's perspective, a very consistent means of basically taking a copy of the data that is a snapshot in time and duplicates the data source, which you can see here on the right in the database manager interface, where each time they're duplicating those layers, you get a copy, copy 1, copy 2, copy 3, making it fairly simple for us, thankfully, and FME to later on go in and find where are all the tables that have been duplicated from the master map to produce a copy that will be that sort of snapshot in time collecting that particular inspection. And so then those duplicate records then get updated and archived after the inspection process has been completed for that particular week. Once we've got that, from the user's perspective, it's actually relatively easy for them to see what's currently active, what has been active, and what's going on from the perspective of just using a pretty simple naming convention. And this particular naming convention doesn't impact what FME is required to do on their behalf to be able to keep everything maintained. The only thing that we need to know for certain is the name of the master map. Everything else they can name as desired, such as an underscore week 5, so that they can keep track of exactly what, which week is currently the active week. So if that's tracking on a standard week by week basis. So while it's a little unfair to refer to the data in GIS Cloud as unstructured, it effectively at this point actually is, because of the way that we've given the workflow to the users. And so what we're ending up doing is basically creating multiple copies of the exact same feature, each copy representing a unique inspection. Through the web interface, it's going to be very, very difficult at this stage for a user to be able to get a sort of bird's eye view overall review of sort of the big picture of the data. And that's really because of what we've tasked the user to do. So this is basically where FME comes in. So everything up until now is set in the scene, but what FME does is, by allowing us to standardize and aggregate this whole historical picture of each asset, and we're also able to use this to be able to provide some performance reporting. And FME makes this easy because the easy to use GIS Cloud REST API combined with the ease of using an HTTP caller makes it actually very easy to be able to retrieve all this data and then to be able to write it out into a format that's easily consumed by the end user, being Excel, which Simon mentioned is now becoming one of the most popular formats to use because everybody has a copy of Excel, very easy to be able to interact with. And so there were quite a few small challenges that the data posed, and that comes even though we've tried to make the form relatively difficult for users to put in incorrect data and so forth. There's always, it's the nature of data that there's always various challenges. And one of the things that there's a whole list of things here that FME made easy. And so the first, of course, is interacting with REST API-based calls. So using the HTTP caller, very, very easy to be able to extract that data. Being able to identify any erroneous data. So we're very easy to be able to provide basic testers against the various attributes that have been updated to make sure that things actually are consistent with our expectations. And then since the way that we've presented the workflow, the user actions on these maps actually defines the data time order, and it makes it, then FME is able to very easily handle those dates to be able to then collate things into sort of a structured way to present back to the user so that we can actually order everything in time and actually get a good picture of what has happened to this particular object over time. So there's also the cases where some of the data sets are partially complete. FME makes it very easy to be able to detect that and get rid of those records where nothing has actually been inspected on that particular feature. Eliminate that out because it now no longer contributes to that history. But if there was an update later on for some reason, then that would be something that FME would still be able to detect in later runs to be able to have everything flow on. We also had the case where there was a mixture of POSIX and string-based date timestamps. And the client was actually using Microsoft Flow from the Power Automate platform for some of their other business processes. But the volume of data that they were going to have to deal with in this case was so huge, it would have completely crushed Microsoft Flow. And so FME, with a much, much better performance, was able to handle this quite comfortably. And the main salvation that we had is because of the maintenance of this master map. It meant that we now had a persistent unique identifier for every single feature that we could use to marry everything up together quite comfortably. And so the kind of workbench that we ended up having, I'm not going to show the actual workbench because far too many transformers, and I think it actually makes things a bit more complex than it needs to be. But the fundamentals really come down to this, where our data stored in GIS Cloud is retrieved via the REST API using the HTTP caller. We then use the JSON fragmenter and a few other transformers to be able to basically conform the data to a standard way of representation and filter out anything that might be a little bit unusual so that then our later logic can work with it much easier. And then from there, it's split into two paths. And this is where it actually gets into the realm of a nice, comfortable piece of clever automation. There's one path that actually takes all the records that are then retrieved for the entire history of a feature that is represented on the master map. And actually, we use a Python caller in this case to sort of bring all the data together into a overall historical picture, timeline, if you will, of everything that's happened. It probably could have been done without a Python caller, but it was just easier given the complexity of structuring the string. And then we use another HTTP caller to actually then go and return that data back up onto the master map. And so this then means that the master map now provides a spatial interface, giving you that overall view of the history for every single object that you have maintained within that master map, which I will note again is separate from everything that's being handed out to the users out in the field. And so you still have that separate sort of controlled access on a week by week basis, whereas you as the back end, sort of back of house individual is able to see a much bigger, broader picture. But then at the same time, we're taking that same data and we're summarizing that together to produce some Excel reports, which is then used both to report back to the client's client and also for internally to be able to sort of look through and measure performance and identify if there's any issues with their work processes. And that's using the almighty statistics calculator, which is very, very helpful in many, many, many cases. And so what the user actually gets on the other end is from their master map, they've got a single attribute on each feature, the history data, which, as you can see here, shows a sort of a timeline history of every single inspection that has actually occurred for that particular feature. And that provides you both an information as to whether or not there was a defect that was identified at inspection, but also how many litres were actually watered onto that location. And so that allows you to sort of see whether or not there is an increase or decrease, or potentially inspect if there was something in some of the other reports that sort of looked unusual. You'd be able to go back into that spatial location, maybe find that 3 or 4 of these unusual ones are all in the same area, and therefore potentially identify some other strategy to be able to handle that. But at the same time, the Excel reports, which are then automatically emailed through to the users, are the ones that sort of really helped out in terms of their weekly sort of monitoring of how their process is going. And that included 2 Excel reports, actually. One that was kind of giving your basic performance reporting, such as whether or not any trees were missed, and sort of how much was done on each day, on each shift. And then the other report is really focusing in on that whole defect aspect and being able to identify trees over the entire collection, where maybe there are things that require additional inspection and resolving of a particular defect, or if there are things where trees have been now identified as being dead trees, or if there's some other kind of vandalism that's going on in the local area. So it allows, from a very simple user interface, a very powerful sort of interrogation of the data. And what really drives that is FME. And so from this single workbench, which we run on demand for the client, we can basically leave all the map management tasks in their hands, because it's a very simple workflow. And then when they need the report on a weekly basis, they're able to come through and basically say, oh, can you please run that for us? It updates their master map with the history, and then provides them with the reports that they need to derive their insights for their business. And now I'll take that as the end.